The next section we're going to be looking at for further math GCSE is simplifying expressions. So pause the video and see if you can remind yourself what an expression is. An algebraic expression is built up of many terms. The terms could include variables. They could always have the operations that break up each term, which is the addition and subtraction. They can have powers. They have coefficients, which are the number in front of a variable, or they can have constants, which is a term without a variable. As you can see, they do not have any equal sign, such as a formula or an equation would have. Oftentimes, another way they could ask you to simplify expressions is to collect like terms. And negative 3 times 2y gives us minus 6y. We've now turned it into a problem like the example above, where we will collect our like terms. 6x take away 3x is 3x, and negative 8y take away 6 more y's gives us minus 14y. And that's our solution for number 2. Once again, our instruction is the same, to simplify an expression. As we have a lot of variables with powers, we want to check and make sure that in this case, we have a multiplication or division. Because this said add or subtract, they're not all the same variables, so they're not like terms, but we can multiply them. We're going to do that by using our index laws. First, let's multiply our coefficients. 3 times 2 gives us 6. Now, when multiplying with your index laws, you can only use the rules if they have the same base. So x squared and x to the power of 1, we can add the indices, so it's x cubed. Y times y cubed is y to the power of 4. And as there's only a single z, our answer will have just one z. This next example is going to work just the same. As it's division, like I said, multiplication or division allows us to simplify these. We start with our coefficients. So 12 over 8 are both divisible by 4. I'm going to use a different color here to help with this, seeing this. So if I divide them both by 4, I'll end up with 4 goes into 12 3 times and 8 twice. So that's going to be my numbers in my final fraction. I next deal with the a's. And as this is division, that means I'm going to subtract the powers. So a cubed minus a to the power of 1. Well, divide by a to the power minus 1 means I subtract their powers. So I have an a squared. The next one is b squared divided by b to the power of 5. When I subtract those powers, I get b to the negative 3. And that means that it becomes a positive 3 if it's in the denominator. An easy way to see this as well is 2 b's from the numerator would cancel with 2 of the b's multiplying together in the denominator, and I'd be left with 3 b's in the denominator. Your final set here, c squared divided by c, gives you a c left in the numerator. And that is our simplified expression for that algebraic fraction. It now wants us to factorize an expression. And this time the expression is 3a squared b plus 6a b squared. So factorizing means to break up into values that multiply to give you a solution or a product. For example, the factors of 12 could be 6 and 2. They multiply together to give you the product of 12. We want to take a look at this and see what can we divide both terms by. So I'm going to start by looking at the number. 3 and 6 can both be divided by 3. They both have an a in them, and they both have a b. There's nothing else left, so now we put our brackets. We say, what would I need to multiply the factor of 3ab by to give us these two terms? Well, 3 times 1 a times another a will give us that a squared, and b times 1. So that will be an a in the front of the bracket. To get the 6, the 3 needs to be doubled. I already have the a, and to get the b squared, the second term needs another b. So that's the expression factorized. For the next example, we're back to the instructions, simplify this expression. As its division, the first thing I'm going to do is I'm going to write this as a multiple of its reciprocal. So I will have 2x squared over 3yz times 4x. Whoops, I need a reciprocal, which means the numerator and denominator swap places. So I will have times 5z squared over 4xy squared. Now, you can go ahead and multiply here and then simplify. I always find it easiest to simplify first because I'm dealing with smaller values then. Checking the numerators and the denominators because it's multiplication. 2 goes into 2 once and 4 twice. I have an x squared in the numerator and a single x in the denominator, so I can cancel 1 from each. The 5 and the 3 won't cancel, 5 and 2 won't cancel, so they're already simplified. I have 2 z's in my numerator, but only 1 in my denominator. So again, 1 can cancel from each location. There's now nothing else left in numerator denominator, so I'm going to go ahead and multiply across. I have 1 times 5 is 5, and then z, x times z. My denominator is 3 times 2, which is 6, and y times y squared. So I'm going to add my indices, and that becomes y cubed. And that's my simplified expression. This final problem wants us to write this as a single fraction. So our goal here, because it's addition and subtraction, is we need to get all the denominators the same. So I'm going to take a look and see what each denominator already has. And they all have a t. So I know my n denominator will have a t. Now I'm going to take a look at my numbers, and I see 4, 5, and 2. Now I want to figure out what number I can turn 4, 5, and 2 all into using multiplication. And that number is going to be 20. So my goal is to get all of my denominators to become 20t. And whatever I do to my denominator, to get it to become a 20t, I'll have to do to my numerator in order to keep equivalent fractions. So for this first one, it needs to be multiplied by 5. So I'll do the same to my numerator. The second value will need to be multiplied by 4. And the third by 10. So I'm going to apply all those multiplications to my numerators. And I'll have 5x minus 8y, and don't forget that negative from in between there, and plus 10z. As there's no like terms, I can't combine my numerator, and even though 3 of these are even, because all 4 terms do not have something in common, such as an even value that we can divide by, we cannot simplify any further. And this is in fact not only written as a single fraction, but in its simplest form. That's the end of our examples for this next part. So go ahead and try section B, and do make sure that you check your answers in the back of the book, and let me know if you have any questions so I can try and help you with them.